Solving systems of equations algebraically. In order to solve systems of equations, we can use one of two methods, either graphing, which we did during the last section, or algebraically, using two methods, either substitution or elimination. The substitution method will solve for one variable. Then we'll substitute this into the other equation to solve for the other variable. For example, we're going to use substitution to solve the system of equations. Again, a system of equations is two or more equations in two different variables. So in this case, we have to solve for one variable. We always look at the equations to see which variable is mostly by itself, meaning it has no other coefficient other than 1. So if we look at our two equations, our first equation has 4x minus y equals 11. That negative 1y is almost by itself, so we're going to solve for y. In order to do that, I'm going to move my 4x over to the other side, and then I have to just divide everything by negative 1 in order to get y by itself. So y equals 4x minus 11. I'm now going to take this chunk of information and substitute it in for y in the second equation. Not back into the same equation, into the other equation. So I now rewrite my second equation as 2x plus 2 times the quantity 4x minus 11. That's the substituted part, equals 18. I'm going to go ahead and solve, and now I'm solving for one variable. I'm solving for the variable x. Go ahead and distribute. Combine like terms. Get our constants over to the other side. And then x equals 4. Once we know what x equals, we can take that information and plug it back into the equation where we have a variable by itself. This will allow us now to solve for y. So y now equals 4 times 4 minus 11. So y is going to equal 5. Once we have what x and y equals, we can write our solution as an ordered pair. So our ordered pair is going to be 4, 5. And that is the solution to our system of two equations. Elimination method. That's the second method we can use to solve a system of equations algebraically. We're going to go through two examples of elimination. In elimination, you want to eliminate one variable by adding the equations, then we're going to use substitution. In order to add, we have to make sure that the coefficients in front of either the x's or the y's are the same numbers with opposite signs. In order to do that, you may have to multiply the entire equation or part of the equation in order to change the signs or to change the coefficients. If I look at my x's, I have 2x and 5x. They are not the same numbers, nor do they have opposite signs. If I look at my y's, I have 3y and negative 2y. They are not the same numbers, but they do have opposite signs. So I want to stick with my y's because I already have opposite signs, which means eventually the y's will eliminate. I do have to get the same number in front of my y's. So what is the least common multiple between 3 and 2? It's going to be 6. So I'm going to multiply my top equation in order to turn y, the coefficient of y, into 6. So I'm going to multiply this top equation through by 2. With my bottom equation, I'm also going to multiply that through in order to turn that y coefficient into 6. So with the bottom equation, I'm going to multiply through by 3. So let's change our equations. My first equation turns into 4x plus 6y equals 24. Note that I distributed that 2 throughout the entire equation. My second equation, I'm distributing the 3. When I do that, I get 15x minus 6y equals 33. I'm now going to add my equations vertically. When I add vertically, I want one of my two variables to drop out. So I'm going to add my x's to get 19x. My y's are going to cancel out, which is what I wanted. And I'm going to add my constants together to get 57. Then I can solve for x to get x equals 3. I now have one of my variables solved for, so I can use substitution to solve for the other variable, to solve for y. When I substitute, I can plug x equals 3 back into either of the two original equations. Doesn't matter which one, I'll plug it back into the top equation. So I'm going to take x and I'm going to plug it in. So 2 times 3 in place of x plus 3y equals 12. I now can continue to solve for y. So 6 plus 3y equals 12. 3y equals 6. Y equals 2. I now have my x and my y coordinate. So when I write my solution, I want to make sure I write it as an ordered pair, 3, 2. Let's do one more example of elimination. Here's another example of elimination. In this case, when I'm doing my elimination, again, I want to look at my coefficients of x and y. Both x and y have a positive and a negative coefficient. I just have to make them into common numbers. So let's say we want to work with our x's. I already have a 6x, so I want to turn the top x coefficient into -6. In order to do that, I'm going to multiply through by 2 for the entire equation. So my top equation is going to turn into -6x plus 10y equals 24. My bottom equation I do not have to change. So I'm just going to rewrite that one. 6x minus 10y equals -21. Then I'm going to add vertically. When I add vertically, notice my x's are going to cancel, but my y's are also going to cancel out. That means I'm left with 0 or nothing on the left-hand side of my equal sign. On the right-hand side, I can still add vertically and get 3. 0 does not equal 3, meaning I have no solution. That is a possible answer. Just like when you graph and you have parallel lines, your lines never intersect, so you have no solution. It may occur that when you do your canceling after you add vertically, you have something equals itself. Let's say we had 0 equals 0 as our solution. Well, what would we call this? Infinitely many solutions, which may happen as well. That's when we graph and we have the same line for both of our equations. So your 3 types of solutions are one solution where you get an ordered pair, no solution where something does not equal the other thing, or infinitely many solutions when something equals itself. And that's what it states down here. If results are always true, infinitely many solutions.